quadratic differential polynomials.
Right. Okay.
And then you want to ask yourself, what's the lattice of substructures of this?
Fine.
So you have to decide, well, am I thinking of just as a differential algebraic Lie algebra? If so, then a sub-algebra would be not necessarily a finite dimensional vector space over F, but just the solution space of a system of linear homogeneous partial differential equations. And that's what I look at.
Okay.
Because various, well-known Lie algebras are there, like divergence zero, divergence a constant, whatever
condition you want to put on,
etc. So that's a richer structure than the first one, where you have, say, Lie subspaces, as you would call them. Although Lie subspaces are differential algebraic Lie algebras, differential algebraic Lie algebras are richer.
So to answer Victor's question, what are the types here? In this case, because it's the whole affine space.
Yeah.
Yes.
You take your pick.
The type would be no. The type would be the whole.
That's differential algebraic Lie algebra.
Would be the total number of derivations.
Yeah.
That you put on.
In this case, it's 1.
In this case, it would be 1, right?
Yeah.
Yeah, because it's ordinary. Because it is ordinary.
When you talk about central extensions, it probably has kind of type 0. I don't quite understand how the central extensions.
The central extension
because they're very
there.
important.
Yeah, the central extension here comes under the second idea of substructure, because the Virasoro algebra is in this first. Is an ambient
The whole thing.
differential Lie algebra, but that kernel is a differential algebraic Lie algebra over constants. So it satisfies obvious differential equations. So it's richer.
So certainly it doesn't fall in this definition. I just took free module, but one has to take also.
Exactly.
Right.
Yeah, sorry, that's how I should put it. That's a free module.
That satisfies some differential equations.
Yeah. So in this question you've got those two. But did you want to restrict it to just some modules over F, subspaces over F?
No, you see, one can prove that torsion should be central.
The torsion part.
Should automatically central. So if you talk about simple or semi-simple algebras, you don't have torsion.
That's right. That's right. But if you want to take central extensions, then you shouldn't throw out the torsion algebras.
Because then I don't quite understand how to put some definition, which includes.
Well, the definition we gave includes them, the torsion parts. Because they just have to satisfy, they have to be closed, and this is abelian, so it's closed under a bracket, trivial bracket. And it satisfies differential, linear differential equation. Derivative equals 0.
Yes, here comes the differential equations.
And
derivative in the directions that you
right. So it fits into the richer way of looking, and also the well-known Lie algebras that fit in that definition and not in the more restrictive one. Divergence, a constant. And the vector fields fit in there too. The vector fields fit in there, sub-algebras, Lie algebra vector fields.
Yes, there's this definition. For all vector fields, it's this definition.
Exactly.
No, you cannot reduce the equation to order 0.
No.
You just see the previous slide.
Yes, I'm sorry. That's exactly. You said exactly what I
This is exactly
and William too. Absolutely, yes.
But of course, to have the geometric usual object as kappa, you have to add also differential equation.
Right.
Plus. Yes. So you have that, that Lie structure, which is differential plus differential equation.
Yes.
For instance, if you take, I don't know, some vector fields fixing 1/4. So So you have the differential equation in two ways, in the algebra definition and plus
Absolutely, absolutely.
You have both. And what I mean that the differential algebra in that general sense have, I don't know, in literature.
Yeah,
And of course, an interesting
that's
question
right.
is how the most general differential algebras are related to the conformal algebras. Is it,
Maybe,
Yeah.
exactly
Yeah.
maybe that's quite interesting.
Yeah.
It's quite interesting.
You know, when I was computing that Cartan list, I was surprised that using the techniques of differential algebra, he of course doesn't use them, and he works with differential forms. But if you use the techniques of the algorithms from differential algebra, you get the same list.
the same as with the simple algebra?
I know, it's the list of intransitive pseudogroup structures on the plane. Cartan has a big article on that.
And he has the
And
same
computes.
list as Fufurito.
Not the same list as Ritz, because those are that's like the ambient ones, like the Vera Sorrow, etc. No, it has the finite time. No, not that list. He gets the same list I get.
And what list is that you?
It's in my file.
Do you have a paper on it? Or it's,
I haven't published it. I thought it didn't. Because various people have talked about the Lie algebra structures on the plane, but they've only done the so-called finite dimensional ones, finite type ones. But these are all the intransitive ones up to what I decided was, I should talk to you, was Cartan's notion of equivalence. And I got the same list. And I have my own list.
And you understood them as differential algebra?
Yeah. Yes.
So probably the answer to my question is it's a negative because the conformal algebra, of course, if you don't take central extension, is exactly as least for three. It's then substitutional types and types.
Oh, right. Yes.
But
Yes,
but
so-
unit is completely different.
Well, the list, if I go beneath the top, in other words, if I go, don't use that definition, but use the one that both Bernard and William described, use that one, then yeah, I get Cartan's list.
Do you have the same indirect product of substitutional type? And especially in non-semi-direct product when there is this additional.
Well, no, I have to ask myself, because I haven't looked at it in so long.
So that's what's
The substitutional types, are they transitive or intransitive?
No, they're
They're transitive. Aha! So I looked at only, when I got Cartan's list, I looked at his paper of intransitive pseudogroups on the plane. These are the intransitive. And so it wouldn't include any transitive ones.
I just want to point out, it's a bit dangerous to draw any conclusions from the planar case in terms of whether or not definitions are equivalent, because there are so few variables involved.
I think you're right.
And we look at the three-dimensional
Yeah,
cases.
I was worried even in that case.
Absolutely, yeah, but I wouldn't advise taking that as evidence that
No.
any overlap is.
I certainly wouldn't take it as evidence, no. No. The more evidence was the fact that Michael Singer and I came up with his claim with no proof that these two subgroups, their translations, were not isomorphic, and he was struggling for a definition of, and you don't like this, of simple group improperly speaking.
Oh, yes.
And
It's
I
a linear
got
case.
fascinated.
It's a linear case that he calls simple group improperly speaking.
I love that because it fits in so beautifully. And his example is,
It's just the linear case where he calls like that.
it reduces to that though. We reduce to the subgroups of GA. The simple commutative groups are worse to calculate. In fact, in none of the literature that I have seen have people gotten past, like Gilman and Sternberg, they don't get past as, yes, they all reduce to subgroups, essentially in my language, subgroups of GA, the additive
Do you
group.
understand this? Actually,
And
equality.
they don't go
No.
any further. Well,
It's,
which one of those would you
I'm,
call simple?
I'm trying to understand what delta 1 and delta 2 are.
It's not clear to me either. And what it means then, do you apply to what?
I don't think they meant derivations
Then
then.
every
Let's ask.
non-trivial homomorphic image
You ask.
is isomorphic to GA, not by the same homomorphism actually, but they're all isomorphic to GA if you're looking at ordinary differential fields. And so he said, well, I think, he didn't, I don't know.
See, they seem to be
He
structural
wrote
constants,
that,
that's all.
this would be a simple
Well,
group.
what's on the right hand side is supposed to be an element of L.
But then he.
But it isn't.
Look, if you-
See what happens when
No,
you
no,
move
no.
down
If you take
from
just
the ambient
EI
group,
bracket
down to the
EJ.
heat equation and gave these a heat
All right, you
equation
take EI bracket
variety,
EJ.
I call it, together
It's
with
not
another
defi- it's-
variety.
Wait.
It's not
Listen,
defined.
listen. No. This is defined for all UI,
And
UJ.
Yeah, it is.
So, right? So I just take the UI to be 1 at one place and 0 in all
Yes,
the
you
other ones.
understand, yes.
So now you take EIEJ, you should just get
Well,
QIJK,
let's see if there's any difference.
some EK, right? That's the structural constant. Now, why is there a delta 1, delta 2? I don't understand.
It's a Q of that is a... Let's ask.
Differential
Yeah,
rational
okay.
functions.
I've been trying to understand this for an hour, so I couldn't
I,
get it.
you know, it seems, the notation seems to say they're derivations, but I don't think that's what it is.
Linear fractional transformations. So using that, I could prove that they weren't isomorphic. So you're right. I mean,
Could you help us understand the definition, actually?
right?
Well, it's,
Yeah, Victor,
and
can we ask
his
a
no, the
question?
notion of equivalence is just this notion of
We
There-
don't understand
Well,
this.
that's our definition too, but we're-
First of all, do you mean just one delta? What is delta 1 and delta
Good
2?
definitions cross category.
What is delta 1, delta 2? Yeah, but what's delta 1, delta 2?
Delta 1 acts on U and delta 2 acts on V.
Yeah.
Like delta 1 minus delta 2 applied to UV is U prime V minus UV prime, which is
Yeah.
substitution.
Yeah. That's
Yes.
a substitution in the algebra.
It's the simplest.
Will we say that again, please?
It's algebraic vector field in dimension 1.
Okay, example. Take delta 1 minus delta 2.
Right.
And Rick really proved.
But what does delta 1, delta 2 stand for?
Two.
Delta 1 stands derivation of the first factor,
group is
and
GA,
delta 2
the
derivation
additive
of the
group,
second.
and one is the abelian one, and
Or
one is
better
this
say
one.
delta 1
The
is delta
substitution
tensor
one.
1,
He actually proves
delta
that.
2 is 1 to tensor delta.
Yeah.
Mhm.
So it's the simplest of the non-commutative Lie algebras.
Yes,
It's simplest.
it does not correspond to
No.
absolutely.
I could prove it's fine.
Impossible.
Yes, actually, I could prove that in that same paper with a simple proof.
By definition.
Yeah.
But however, Q might not be of that form.
No, Q can be arbitrary polynomial in two variables, delta 1 and delta 2.
So how do you evaluate it on it?
Okay, let me write an example.
Yeah.
Yeah.
So the bracket is not A-linear.
For example, delta 1 squared
No, it isn't.
no,
It's
no,
only
it's not.
C-linear.
That bracket is not linear.
Yes. Mhm.
Yeah, in this case, it's a C-linear.
But if you take the algebra of
what
a
else?
linear algebraic group, it does not happen that
Okay.
it is linear.
For example, this, how do we write it? So, apply,
I understand.
you
Yeah,
apply
yeah,
to UV
Yeah.
is equal to U double prime V minus UV double prime plus V prime.
Oh, I
Yes,
see.
yes, yes,
Yeah.
yeah.
Oh, okay.
This
Okay.
also
Yeah.
the-
Oh,
Yeah.
okay. Delta 1 is differentiated on U and delta 2
This
is
gives
differentiated
also
on
in
V.
Yeah.
Ah, okay.
Yeah,
Yeah.
Ah,
All right.
Yeah.
That's a
no,
that's a strange way of writing.
symmetrical.
No,
Yes,
differential
I have a
operator.
question. Your QI,
Okay.
D1,
So they are differential operators.
which are
About two
polynomial
variables.
in delta 1, delta 2, which coefficients?
Okay, all right. Okay.
Yeah, this is something which I cheated a little.
So what we interpret,
I can do it only with constant coefficients.
so what we interpret is like.
Yeah, yeah,
Right.
yeah.
Okay.
That's all right.
Yeah. So it is given by differential polynomial maps.
See,
Yeah,
Right.
it's interesting.
It's given by differential polynomial maps, and the delta 1 is the UI derivative and the derivative is the Vj derivative.
I understand. Yeah.
But that's a very poor, very bad way of, sorry.
Must
Right.
It's
It's not, I don't think it's the well, but that's the notation they use
It has to be
anyway.
bilinear. It's a bracket.
Yeah.
Do the polynomials have to be quadratic? Differential polynomials.
No,
They can be any.
but you notice it is in your read Cassidy list. So, this example. No, so you go up to degree, what it was, 6, 9?
Oh, degree 6.
Yeah, here. X is delta 1, Y
Yeah,
is
up to
delta
9, up to 9.
Why is
degree
delta
9 there.
Oh.
Degree 9.
Yeah, this is the
So that's actually the order, right?
Oh,
Those are
okay.
actually the order.
order what?
The order of derivation. Oh, no, not order. No,
No, X is delta 1
the
and Y
order
is
is
delta
3.
two.
3. The order is 3.
So
right
X
now.
is delta 1, Y is delta 2.
Yeah, that's right.
Yeah.
So it's order 3.
And all
It's
that
order
gives
3.
Lie brackets.
Yeah.
Yeah.
This is a complete list of.
So-
But one
So-
is Virasoro and another is.
Yeah.
So those are all, right? Isn't it all?
Very surprised I didn't think so.
Now, do you have an a priori bound before you know this? Do you know the bound of the order?
So it's one of you.
You know, you have to compute cohomology. Bound is 3 minus delta.
Ah,
The
right,
delta
right,
is
right,
one
right, right,
for
right.
which cohomology is not trivial.
Right, you compute
So
it.
cohomology gives us a bound.
Thank you.
Because I had the most fun.
Now, okay.
I felt like saying, oh, thank you, Rick.
So this list is
Did all the work. Rick did.
more isomorphic
That's what I like.
transformations, I suppose.
Yes, up to all of them are known as
Yeah.
Yeah, right.
At least we know what Rick meant by isomorphism. Yeah. But interesting thing is that Rick has in a footnote that Colton showed him how to, these are just group laws he's looking at, shows him how, where to put the structure of an actual group with points on power series rings, on the maximal ideals of power series rings in transcendental constants. And those groups all turn out to be pro-differential algebraic groups. They're projective limits of actually unipotent differential algebraic groups. So, but Rick wasn't interested in that, I don't think. He was interested more in the group laws.
But this seems to be richer than differential algebraic group, right?
Yeah. Yeah, he died just in the middle of that project. Just too bad. Yeah. So I have to look at all these things. Get back to that. Well, thank you very, very, very much.
You're welcome.
Oh, you didn't meet Leon at the station?
Yes.
Yeah.
Meeting with.
So, thank you.
So,
Oh, very happy to see you. I'll be writing to you.
Thank you.